All right, let's jump right in. I want to talk about reframing how we think about science. So for a second, just forget the lab coats. Forget the super complicated formulas. What if we looked at science as, well, as a toolkit? A really practical, powerful toolkit that you can use every single day to make sense of the world around you.
So, if you're someone who thinks science is just, I don't know, boring facts and memorizing the periodic table, I really want you to stick with me. Because at its heart, it's not really about what we know. It's about how we explore and understand everything. It's a whole different way of thinking.
And this really gets to the heart of it. Think about these two things. You've got the magnifying glass, right? That's for super careful, intense observation, noticing all the little details. But just looking isn't enough. You need the compass. You need a purpose, a direction. It's the mix of those two things, detailed observation plus a clear question, that really drives every single discovery.
Okay, so here's the game plan. This is the toolkit we're going to build together today. First, we'll talk about a whole new way of seeing things. Then we'll get into the art of simplification. Yeah, really. After that, the incredible power of precision. Then we'll learn how to predict and test our ideas. And finally, we'll wrap it all up into an everyday science toolkit that you can start using, like, right away.
All right, first things first, we need to get into this new mindset. See, the real magic of science, it isn't finding the final perfect answer. Nope, it's all about the process. It's how we know what we know. It's this active journey of discovery where observations lead to measurements, ideas get tested, sometimes they get revised, and you know what? Sometimes they get thrown out completely. And that's okay. So, let's grab our first tool. And honestly, this one might be the most powerful and kind of surprising. It's the art of ignoring things. Seriously, you heard that right. To understand a really complex world, sometimes the smartest move you can make is to decide what details to leave out on purpose.
And this is what we call a scientific model. Now, this isn't about being lazy or taking a shortcut. Not at all. It's a really deliberate choice. We basically zoom in on what's absolutely essential for the specific question we're trying to answer, and for just a little while, we push everything else to the side.
Let's make this super real. Picture this, a cricket match. The batter just smashes the ball for a massive 6. It's sailing through the air. Your job? Predict exactly where it's going to land. Now think about all the details in that moment. The crowd, the weather, the pitch. What do you actually need to focus on?
Okay, so let's start simplifying. To figure out where that ball is going to land, do you need to know the brand of the bat or the color of the ball? Of course not. That's noise. We can totally ignore it. But what about the ball's mass, the speed it left the bat, the angle it took off at? Ah, now that is absolutely crucial. See what we just did? By choosing what matters and what doesn't, we just built a model.
And look, this isn't just for simple stuff like cricket balls. The great physicist Meghnad Saha, he wanted to figure out something incredibly complex. Why stars are different colors. And his big breakthrough? He ignored almost all the crazy complexity. He just treated these giant, fiery stars as if they were nothing more than hot gas. And that simplification, that simple model, let him connect to their color directly to their temperature. It was a massive, massive discovery. And it all started by ignoring the details.
Okay, so we've seen how powerful it can be to ignore some details. But there's a flip side, and it's just as important. Once you've made your simple model, the details you decided to keep, oh, they have to be perfect. And that brings us to our second tool, the power of precision. Because sometimes getting the words and the numbers exactly right can literally be a matter of life and death. And I'm not kidding about the stakes. Let me tell you about a real-world incident. A huge passenger jet just ran out of fuel, mid-flight. The pilot, incredibly, had to glide this massive plane down for an emergency landing. And the cause? It wasn't some crazy mechanical failure. It was a simple, tiny mix-up in units.
You see, the ground crew needed to load over 22,000 kilograms of fuel, but they did the math using pounds instead of kilograms. And that one tiny error meant the plane was short by 15,000 liters of fuel. That's the power of precision, or in this case, the terrifying danger when it's missing.
So the big takeaway here is that this isn't just about preventing disasters, right? When we use precise, standard units, it means a scientist in Tokyo can perfectly understand and build on the work of a scientist in Toronto. It means when you go to the store and buy a kilogram of rice, you know exactly what you're getting. Precision is what builds trust and lets us build knowledge together as a planet. All right, on to our third tool. This one is all about being able to look into the future. Because you see, great scientific ideas aren't just there to explain things that have already happened.
Their real, incredible power is in their ability to make predictions about what will happen next.
And this is where we have to get really clear about one specific word, theory. You know, in everyday language we say, oh, I have a theory, and it means a hunch, right? A guess. Well, in science, it is the exact opposite. A scientific theory is a rock-solid, well-tested explanation for why something happens, and it's backed up by mountains and mountains of evidence.
Let's just say that again so it really sinks in. A theory is not a guess. It is not an untested idea. It's actually one of the highest levels of understanding we can achieve in science. It's an explanation that has survived every test we can throw at it.
But, and here's the cool twist, the most exciting, game-changing moments in science, they often happen when a prediction, one based on a really solid theory, turns out to be wrong. Now, this isn't a failure, not at all. It's an amazing opportunity. A failed prediction is like a giant signpost that says, hey, your understanding is incomplete. It forces scientists to go back, check their assumptions, and dig even deeper. That is how real learning happens.
Okay, we've got our tools. We've got simplification, we've got precision, and we have prediction and testing. Now for the most important bit. How do you actually take this toolkit and use it in your day-to-day life out there in the real world?
Okay, let's take something you might see going viral online. The claim, eating food during a solar eclipse is harmful. Now, instead of just believing it or dismissing it, let's use our toolkit. Step 1. What's the real question here? Step 2. What's the actual mechanism? Well, an eclipse, it's just a shadow, right? The moon is blocking the sun. Step 3. Let's test that logic. Does food normally go bad if you leave it in a shadow for a few minutes? No. Step 4. Conclusion. There is absolutely no known physical, chemical, or biological reason why this would be true. Boom. You've just used scientific thinking to cut through the noise.
Let's try another one, just for fun. No calculators allowed. I want you to make a quick guess, a rough estimate. How many liters of air do you think you breathe in a single day? Go on, just give it a shot.
Ready for this? The answer is somewhere around 10,000 liters. It's a huge number, right? But here's the thing. What's really important isn't getting the number exactly right, it's the process of reasoning it out. You think, okay, I take maybe 15 breaths a minute, each breath is about half a liter, and pretty soon you can get yourself into the right ballpark. Science values that kind of back-of-the-envelope reasoning just as much as super precise calculation.
And that's really what it all comes down to. You know, we have to remember that science isn't some cold, robotic thing. It is a deeply, profoundly human adventure. It's driven by our own curiosity, our creativity in dreaming up new ideas, and our amazing ability to work together and learn from each other's mistakes and successes.
So there you have it. You now have the toolkit. You've got the magnifying glass for careful observation, and you've got the compass for asking purposeful questions. The only question left is, what are you going to examine first? What everyday fact or viral claim are you going to put to the test? Go on, happy exploring!